Hi, welcome to the presentation of the IoT fire detection device, the project by Group 1. My name is Dallas Simons. I am a Pi configurator for the project. I was responsible mainly for the source code and overall application development.
Hi, my name is Adrian Sommersinger, and my main role in this project was to be a report writer. So what that involved is me prioritizing the design and the actual requirements of the device.
Hi, my name is Luca Favotto, and my role in this project was the prioritization of the diagrams and figures, and also in the overall report writing of the project.
Hi, I'm Matthew Napoli, and like Dallas, I am a Pi configurator for this project. So my responsibilities included the prioritization of the infrastructure and the implementation of the device. So this included the physical configuration of the hardware and also the research of possible real-world applications of our IoT device. Our problem space. Throughout the course of this subject, we have come to the realization that the problems with bushfires and explosions are detrimental to its environment. Through the research and reflection, we have gathered that fires and natural explosions occur frequently without detection and mitigation responses. Last year, there were more than 24,000 fires and explosions in New South Wales alone. In this time, there were 10% of response times by Fire New South Wales exceeded 11 minutes, and 50% of these response times also exceeded 7 minutes and 30 seconds. Now, this is critical because homes, offices, and human lives are being lost due to the crucial seconds being deprived by a lack of reliable fire detection technology. Our solution. So our solution is a fire detection device that will notify a user and the fire departments of possible fires. It will have a temperature threshold of 75 degrees Celsius and will also be capable of detecting uprising trends in temperature readings to detect the potential fire as early as possible.
We have many system objectives that we aim to achieve with this project. So our first objective was real time. This means that users are able to gather data from the Pi as soon as it is collected from the environment. Next is compatibility. This means that many IoT devices can work together so that in large office spaces, the data gathered can be understood. Next is minimalistic. This means that the information gathered from the Pi is able to easily be understood from users without too much depth in the information. Next is intuitive. So this means that the design of the Pi is easy to understand and configure for the users. We also have included aesthetics. This means that the Pi itself is aesthetically pleasing and not hard to look at. We've also implemented security, meaning that information is encrypted and not able to be hacked. So our high-level design. The high-level design is a design of the data flow from the Pi. So first we have information gathered from the sensors, which is then sent to the Pi. The Pi gathers this information and sends it to the Pi and to the database, and also to our end devices, being the PC, cloud, and mobile phone.
Alright, so I'm going to be just going over some of the topics we're going to be talking about later in the presentation. So we're going to be talking about the types of notifications, machine learning, and the hardware and software that we decided to implement as a group. Alright, so the type of notifications that we are going to be going through is email, Twitter feed, mobile application, text message, and third-party notifications. So in terms of third-party notifications, what we mean here is there's actually a specific app that the New South Wales government runs called Fires Near Me. And what that does is it allows users to see fires that are in a watch zone that they've set, which could be ranging from 5 to 50 kilometers of a radius. And what this means for us is that when a user is notified of a fire through our IoT fire detection device, this will send this information also to the 000, as in the fire brigade. And once the fire brigade is notified of any fires, they actually upload this data onto their system. That way, the wider public, so anyone without our application, will also be able to see fires that our Raspberry Pi has notified them of. So here is an example of what a mobile application could look like. So over here it says, hey, quick reminder to double check your sprinkler system is functioning properly. We decided to implement notifications like this to surprise and delight the user, just to make sure that they are keeping those unintended items attended. So they like, say for example, if they've accidentally left their gas heater or their gas stove unattended, it will just occasionally remind them, like maybe just check up on it, just to make sure that they haven't left that unattended. There's also a text message that indicates them that a fire has been detected, and it's just asking them to evacuate the premises as safely as possible. Alright, so here we have a Twitter feed notification, and this one here explains that there has been a fire detected on the premises, and it actually displays the temperature that has been read by the fire detection device. And it also displays that the authorities and linked users have been notified. So what we decided to do as a group is we decided to add this feature called linked users. And what that allows is, say for example, if a person was using our fire detection device and they wanted their relatives or family members that lived in external locations to be notified of a fire that is detection on their premises, they can actually register their family and relatives' their mobile numbers, so that in the case of a fire, they get sent a text message as well. So here we have a Twitter notification that shows it just shows that there has been an increase in the temperature in the last minute, and this is just an example of what would happen for an early warning that would happen for the user.
Machine learning. So machine learning is a calculation of variations in temperatures between readings. So machine learning means that if large variations are calculated with trends, it results in notifications being sent to the users. So this means that after a large amount of data has been collected, the Pi is able to understand variations in temperatures to further notify the user of when fires are potentially occurring instead of events occurring around the house or office. So in this project, we did not implement machine learning itself, we implemented a script that emulates machine learning.
So these are our hardware considerations, and the first one is the Raspberry Pi Zero wireless, which is the main component of our fire detection device. The Pi is the backbone of this project because this is where all the inputs and outputs are gathered and processed, and where all computing is completed. Our second hardware consideration is the Pimoroni Enviro P-Hat, and this device is going to be used to capture the environmental data. There are 4 sensors on this device, but for the purpose of this project, we will be just using the temperature sensor. Our third consideration is the user's personal device, which is another piece of hardware that will be used by the user to view the data gathered once notified. And it also has the processors from the Pi and the Enviro P-Hat.
Okay, so for some of the software that we've used in our detection device, we have gone with SQLite in order to store and record temperatures over a period of time, as well as Node-RED, which runs on Node.js, in order to accurately represent the functions and how they will flow along. Now, how does the prototype work? Well, the prototype is built in with Node-RED nodes, which all run under a single flow. Now, some of these nodes include the Enviro P-Hat node, which will gather the information from the Enviro P-Hat and then send that through a message payload. We have the database nodes, of course, which run on SQLite in order to store the temperatures. We have encryption and decryption nodes in order for data transfer safety. We have Twitter nodes, which will require a Twitter API in order to send out Twitter updates. Email nodes to send out email updates, as well as dashboard nodes in order to show and accurately portray the current temperatures on both the CPU and the sensor, as well as change nodes, which will let us store variables such as the current temperature under the flows context or global context. Now on for a demonstration.
Welcome to the demonstration of the IoT fire detection device. Start on the top left with a CPU temperature injector that's run every 5 seconds. This is then passed through a batch command which will run vgen_cmd to measure the CPU temperature. A function is then run to ensure that the CPU temperature is dashboard friendly and is then displayed on a gauge and a chart, as well as setting a global variable. The same thing for the EnviroFAT, except a 5-second delay must be added because the EnviroFAT does not have a interval. It just sends it through. The temperature function is also the same, where it makes it to a 2 decimal point and is then outputted to the dashboard, a debug, set global temperature, and 2 global fire detected and fire spike variable updates. We see on the move this. We see on the in the debug, it'll pop up. Over here, we have the global variable injectors, which will begin on the flow startup. The first one will inject the global fire detected boolean, which starts as false. Fire spike, which is also false. The previous temperature, which has a 1-minute delay, but it is repeated so that the previous minute temperature is recorded and is able to be detected for fire spikes, as well as the spike temperature, if a spike does occur. Now over here, we have the global fire detected variable update. Now what this function does is if the temperature from temperature function is higher than 75, the global variable fire detected will be set as true, and this will impact the flow in further down below. The same thing for fire spike. If it recognizes that the previous temperature has gone up by 10 degrees over the past minute, it will set the fire spike detected variable to true, and it will set the global spike temperature to whatever the spike was. Else it will stay as false. Now down to here, we have the SQLite database, which stores and records CPU temperature and sensor temperature. It uses an injector that is run every minute, and an insert SQL line, which will insert the data into the temp data table, which includes the temperature, CPU temperature, date, time, and it uses the global variables current temp and current CPU temp. The fire detected injector is ran once every 10 seconds, and the function that is used is pretty similar to the global fire detected variable, but it will run every 10 seconds and make sure that if the fire detected global variable is changed, it will send out a message payload, fire detected, the current temperature of the sensor is, and it'll get the current temperature, and will return, else it will return null. Same for the fire spike, every 10 seconds, only difference is it will get the current temp and the spike temp in the past minute. Now the email is set up using Gmail, fire detection sensor uts@gmail.com. Right now it's set to itself. The debug is for if a message does come through, so we do know in the console. And Twitter functionality needs an API key. Unfortunately, we're not able to get one from Twitter, so that is unavailable. Now I can quickly show the dashboard right here. So it's just a current thing. I'm going to quickly change the 75 to 32. Let's see if I can heat up this thing, deploy it. Yep, let's see if I can heat up the Pi. Let's give it a second. Seems to have frozen. Oh, there it goes. It's sending through now. And there we go. Fire detected. And that is the end of the demonstration.
Alright, so in conclusion, our group gained some valuable knowledge on the importance of IoT in the real world, and we gained some insights on such things such as the security aspects of the IoT and also performance of Raspberry Pis and whatnot. We also gained a valuable amount of insight on the severity of fires in New South Wales and what we could do to make an impact on that and to help out the fire grid. Many hardships were faced throughout the course of this project. However, we remained positive and we were able to overcome these obstacles and hence manufacture an Internet of Things application that we are pleased to call the IoT fire detection device. Thank you.
Thank you.